Welcome everyone to BTT 151, Fundamentals of Electricity. I'd like to go over your Unit 9 homework. Question 1, what is the most common type of AC waveform? That's the sine wave. Question 2, how many degrees are there in one complete sine wave? So I've drawn the sine wave here, where time is on the x-axis or the horizontal axis, and voltage is on the y-axis or the vertical axis. So the common degrees, here's 0 degrees, here's 90 degrees, here's 180, here's 270, and here's 360 degrees. So 360 degrees in one complete sine wave. Question 3, at what angle does the voltage reach its maximum negative value on a sine wave? That occurs at 270 degrees. Question 4, what is frequency? Frequency is how many of these occur per second, so cycles per second. In the United States, the frequency of the AC sine wave is 60 hertz, or 60 of these sine waves per second. Question 5, a sine wave has a maximum value of 230 volts. What is the voltage after 38 degrees of rotation? So the algebraic equation we're going to use, V instantaneous is equal to V max times the sine of theta. We plug the numbers in. V max is 230, and then we calculate the sine of 38 degrees multiplied together, 141.6 volts. Question 6, sine wave has a voltage of 63 volts after 22 degrees of rotation. What is the maximum voltage reached by this waveform? So we're going to manipulate this expression a little bit, this time solving for V max. So V max is going to be equal to V instantaneous divided by the sine of theta. So plug the numbers in, 63 divided by the sine of 22 degrees, 168 volts. Question 7, a sine wave has a maximum value of 560 volts. At what angle of rotation will the voltage reach a value of 123 volts? This time we're looking for the actual angle. So again, if we manipulate this original expression, sine of theta is going to be equal to V instantaneous divided by V max, but we're not looking for the sine of theta, we're looking for theta. So to actually get the angle, we're going to have to take the inverse sine of that expression, V instantaneous divided by V max. So if we plug the numbers in, theta is going to be the inverse sine of 123 divided by 560, gives us 12.7 degrees. Question 8. A sine wave has a peak value of 433 volts. What is the RMS value? And remember, RMS stands for root mean square. So the expression VRMS is equal to V peak divided by the square root of 2. So if we plug the numbers in, 433 divided by the square root of 2, it's going to return an instantaneous voltage of 306 volts. Question 9. Sine wave has a peak-to-peak value of 88 volts. This time, what is the average value? Remember, average value is the same as the DC value. So the peak-to-peak value of 88 volts, remember on a sine wave, peak to peak. So to get the actual peak value, I have to take that expression, divide by 2. So 88 divided by 2 is going to give 44 volts. And then to calculate the average value, take 44 volts and multiply by 0.637, 28.02 volts. And lastly, question 10. A DC voltage has an average value of 68 volts. What is the RMS value? So VRMS is equal to V average divided by 0.9. So if we plug the numbers in, 68 divided by 0.9 will give us an answer of 75.5 volts. Thank you.